embarked with ARTlab, Green NIU, and the Institute for the Study of the Environment, Sustainability, and Energy.
We like to say ESE.
ESE.
Yes.
ESE, Green NIU, and ARTlab. We have embarked on a collaborative project. We hope to God this works. We've never done it before, so we don't have a format. We're nervous, uncertain, and a little scared that we might not be successful. But since we don't know what success even might look like, we're kind of okay. We can just say, well, that must be it, because we did it. So far, here's what's happened so far. Melissa wrote a grant for us to the DeKalb County Community Foundation for, I don't know, $5,500 más o menos, for the funds to undertake a green roof research and education project. What we have so far is a green roof sample, so we can go out onto the balcony and have a look at the components of a green roof, which are some, you know what it looks like? A planter. Mm-hmm. Guess what? That's what it is. It's a planter. It's got some fake dirt. It's got some sedums. They're fat and juicy. They look nice. If they were on the roof, you wouldn't even see them. They would be invisible. At any rate, we're embarked on that project. We're also embarked on another project that Frances Whitehead introduced to us, sort of, on Monday last, called the Living Laboratory, which is an idea we pretty much stole completely from Mary Miss. Mary Miss is an earthworks artist living in Southern California and teaching at UC Irvine. She proposed this amazing project that wasn't funded because it was too big. So we're stealing it. We're going to try to do a little tiny version of it. That's what we're up to. So we're looking at the intersection of art and science, really. And I am not a scientist. I've been told that by people who actually know what scientists do, and I'm not one. And I believe them. I also can't sing. Experts have also passed judgment on that. So tonight, what we're going to talk about, Melissa Lenczewski will talk to us a little bit about water, which is everywhere, and it's a big issue. And Melissa Burlingame will talk to us about Green NIU. We'll find out what's up with that. It's sort of something that got born out of Thor's forehead, all of a piece. So we'll just see where we go with it. Everybody knows what they're talking about, but we want you to ask questions. We want this to be a responsive kind of conversational evening. So as you suddenly say, what's wrong with the DeKalb water? Or what's so big about, I don't know, green roofs? Or why should I care about fill in the blank? Then ask it, and we will do our best to make an intelligent response. What do you think of that?
Yeah.
Okay. All right, let's go.
Let's have Melissa go first.
Let's do it.
It's easy. It's a 50-50 Melissa.
That's why we If your name is not Melissa, you cannot work in this. So, give up, Jeff.
Melissa and I actually worked together for quite a few years now, but so it's been a nice partnership. But Karen invited me to come and be kind of a green roof expert, and I was like, I'm an expert? Huh? That's funny, but I think I know a little bit more about it than a lot of other people on campus. Sure. But we were interested in getting a green roof built on campus. Turns out it's not as easy as saying, hey, can you build one? And so we decided to take a strategic approach to getting the administration's support, hopefully, to eventually build a green roof on campus. But it's not something that's going to happen in a year. This is probably going to be at least a 3, probably a 5-year project. And my hope is that I'll still be here after I graduate to be able to see it through.
You'll be a grandmother.
Thank you. But so the DeKalb County Community Foundation supports a lot of community initiatives and a lot of the NIU departments for things too. They do a lot of young education, adult education. So we were interested in kind of taking that two-pronged approach of we're going to educate the community on what a green roof is, because if you ask a person, do you want a green roof on your house? What is a green roof? They don't need that. That concept hasn't really filtered through down from the scientific level to the general public, whatever the general public is defined as. And so there's all kinds of green roofs. We just want to do a simple one. It's called an expensive green roof, which means it's very easy to take care of. It's got a very short soil media, so it's only about 4 to 6 inches of soil, which is genetically, not genetically, sorry, it's engineered so that it's not too heavy. Because if you put all this soil and all these plants on top of the roofs, your building load capacity may or may not be able to hold it, which is one of the issues we're dealing with. So get the community on board, students, faculty, getting them to know what a green roof is, and also the community members. One of the things that the DeKalb Community Foundation loves are town and gown, partnerships. And since I'm on the city's environmental commission, I was able to talk to them and say, we would like your support from environmental studies, the ESE Institute. And so they're like, oh yeah, absolutely. Why not? We'll have a site to show it around down the city. They're even like, oh, well, maybe we can do this. And so they have ideas too. So knowing that we have that support is really good. The other arm of this is the research, because you can love the idea of a green roof, but will it work in DeKalb? Yes, but we need to research. So Melissa is a hydrogeologist. I'm in the geography department, and my main advisor is a biogeographer, so he deals a lot with plants. And so I've been working with them on trying to develop a research design that we can put into place for the next couple of years to actually get that data. And then also the company that donated the first panels that we have in Green Grid, that company has worked a lot in the area, and so I'm going to be working with him to get data from other sites to start to compile that data, so that not only will we have our own data, but we'll have different regional data sets to work with as well. And then hopefully we'll have the community support and the research footing to actually do it on campus. And by that I may, it won't be necessarily affordable, but a green roof can last up to 100% longer than a traditional roof. So if your traditional roof lasts 15 to 20 years, a green roof can last, if maintained properly, anywhere from 40 to 50 years. So it's a big investment.
So is there any questions or comments about green roofs? Do you guys like this idea?
Is that sort of prolongation of the life of the roof because of the heat reduction it gives, or what?
There's no UV touching the roof at all.
Right.
The water really get into it.
Yeah. Some of the benefits of green roofs is it, it slows down the water. So, we have a kish that floods. So the water is retained a little bit longer, and it's allowed to filter and cleans the water a little bit instead of the immediate runoff into our water sources, which Melissa can talk to you about a lot. And then it's, reduces the, or can reduce the, the UV directly on the, so you're getting into terms that I'm not so familiar with, on the roof. So there's black top roofs, there's white top roofs, and a lot of times they just, they'll start to peel up from a lot of the solar and wind wear and tear. And this way the plants are taking the brunt of that instead of the actual materials on the roof. It also should, if done right, should reduce heating and cooling costs in the building, because it acts as another layer of insulation.
You want to talk about the modular system of the
Right.
roofs that we're talking about?
Yeah. So the expensive roofs, you can have a grid system, a modular grid system. So the one that we have, you can, I'm sure Karen will let us go out and see afterwards.
I can't wait.
If it's light enough
Free
out
today.
still. Yeah. But the benefit of a modular system is, say your system starts to leak in one area. You can pull that grid out, recycle the plants, reuse them, plant them in something else, and put a new one in. And you don't have to tear up a whole bunch of, landscaping to do it, which is one of the things that we love. If you talk to the company, they'll say it needs minimal maintenance. So just have to initially, plant them, water them, weed them. And then after that, it's just making sure you're going up there on a periodic basis to, see, is there any pooling water? Are you seeing visual cracks? Is there some, those types of things. I mean, it's not a zero maintenance thing, which is something that most people think our roofs are, but we should be looking at our roofs made periodically anyway.
Well, I should tell you, too, that we've designed some research trips. So we planned a green roof trip for this coming Saturday in collaboration with the NIU Art Museum. So I think it's $15 to go to Chicago. We'll have a guided tour at the who knew that there was such a thing, the Chicago Green Technology Center. So when you go there, there are solar banks. You can see 15 ways that solar can work in your house. They've got a little tiny solar test thing that's so cute. I want to go live in it. There's an amazing library full of just books on all this stuff. It's an incredible resource. There are samples. They have seminars. And they have a bunch of green roof test sites there, so you can look at them. You can find out how to compost. You can find out all kinds of stuff. So we'll have a guided tour of that place. And go over to the Peggy Notenberg Nature Center, which has not a modular green roof, but a field of grass. Oh, as does the green roof. Also, it's a LEED building. It's very exciting to have a LEED building. I don't know what that is yet.
LEED,
Yeah.
leadership. What's LEED stand for?
Yeah, leadership. I don't know the E's is environmental. The D is about design.
And the other is probably
Energy and environmental design.
Yeah, that's it.
It's a standard that you can meet by doing different environmental and energy savings. So really, we're building the way we should instead of the way we do. We're building for longer term instead of for saving money immediately. So we're putting in solar panels to reduce the energy. We're making sure that the ventilation is properly managed.
There's so many points for doing different environmental
There's
things.
water, there's how close are you built to a public transportation system? That could be part of it.
Parking spaces that are smaller for compact cars to encourage more compact cars closer to the view.
How many are dedicated for community, what is it called when you ride with other people?
Ride share,
Carpool. By the state of Illinois, we are required for all buildings that go in that are financed by the state, they have to be at least silver. They use like silver, gold, platinum. We have to be minimum silver. So the new buildings that are going in, even we're doing Coal Hall or renovating that, it is going to at least be silver. One of the things that we're pushing for is that they try to do a few extra things to make them maybe gold, maybe get to platinum. We saw one of the science buildings at the Lloyd College. Well, what they were able to do is use student project to look at the LEED and how to get extra points, and they took students' recommendations, and they went from a gold to a platinum just because students were able to come up with extra points for the building.
Because the students had ideas that the architects never thought of, which is one of the things that we, working with parents, hope that ARTlab will be able to do, is come up with ideas that traditionally, we're not going to think of because we're stuck in a box, or we're trying not to be, but,
But it's invisible to ourselves.
Yeah.
It will be fun.
Yeah.
Well, that's what Francis was talking about last week, the idea of the embedded artist and bringing that, just having those other ways of thinking inside.
Because LEED, has a lot of great things with light and how you deal with space and open spaces and things. I'm used to, I'm a scientist. I think in blocks and everything. And scientists can work with artists to come up with maybe better ways of making that light and the space work better than what I can.
Well, I just want to ask a question based on things that people were asking me after hearing Francis speak last week. That kind of ties into what you're saying. The question I got a lot was, how is this art?
We don't know.
I think that's what this tonight is starting, is the discussion of how do we make it art? How do we make these concepts that are so grounded in science become something art so that other people can understand it in different ways? I think that
I want to say something about that because because that question, how is it art, isn't much different from how is it science, and the split between the disciplines was imposed at a time when knowledge was increasing so rapidly. No one could know everything anymore. So what we now think of as our separate disciplines came about as a way to make it possible to study things that seem to belong together. The arts traditionally have asked the very same questions that scientists ask. We're wanting to know about the nature of what is life about, how does it occur, what's the point anyway, and what do we have to do with anything? What's going on? Artists are asking the same question, And we answer it often in very similar ways. So I would just say, read Leonardo's sketchbooks, and the question of art and science suddenly vanishes. The beautiful drawings of helicopters and war machines, and asking questions like, why are there clam fossils on the top of this mountain? And trying to figure out how water got up there so that it could come down. We've always been asking those questions, and I think that what we should do is not ask, how is it art? But just say, how can we help make something happen? Our art mind, our way of thinking. I think that, to me, the truth of the matter is that the poetry is a very basic discipline that we build on as artists. That way of thinking of taking away everything except the bare words that form the image. The images seem to percolate up out of that's where we're coming from. And science, I don't know what your base, but we share some platform. We share some curiosity. We share some human hardwired thing. Yeah.
And I believe that one thing that design is somewhere in between the fight for my students today, because we are really in between.
You're the ones.
And the functional.
Exactly.
So
that is it. The question is answered through design. It will always be answered through design. Your pure research and mine don't have anything to do unless there's design to make it legible. So that's our answer in one word.
And I know from a science point of view, we always have to express our data some way to make it accessible to people. Just as an example here, you know, I could never come up with something like this. I'm not an artist. I just put numbers and quantify things. But just the way this visualizes the science behind it is great. Of course, once I hold this up real quick, this is about water, and this comes out of the National Geographic issue. It's a special issue on water, and I'll pass this around afterwards. But this was great. You know, the bigger the bubbles and how it's got cows in it, showing how much water is used for it to have a cow versus using, you know, an eggplant uses very little water. How much water is used to make a pair of jeans versus down here in a cup of tea. You know, this idea and how it all flows and how you can learn so much information from something that's so beautiful, I could never do. And so this is that intersection there. How can I take this information and really make it accessible to people? So to me, that's one of the things I think is great about this is how do I take these very complicated scientific ideas and make it into something that I can hang up and people can learn something and still even think it's beautiful too. So I'll pass this around. I mean, and on the back it's just got about the world waters, and I'll be talking. You know, I can talk more about water and water use and everything later on.
And you might be able to see this big blue splotch. There's only like 3 or 4 big blue splotches of that, and Francis was saying that we're right on one of them.
Yeah, the biggest freshwater body right there. And
Great Lakes.
Oh, there's the Cascades. Oh, there's Lake Victoria.
so if you guys want to just see this, so this is another answer to that question that I think, from the science point of view, something that helps me out.
Exactly, it makes it visible.
Yeah,
It
makes my
We're only confined by what we decide to be confined by.
So any other questions?
Tell us about water.
Oh, okay. Well, one of the things that Karen has introduced I'm actually also in the geology department. I'm actually what's called a contaminant hydrogeologist. What I get excited about is pollution. I mean, it's kind of strange. I took a group of students this last Saturday to the landfill up in Rockford, and I was all excited, and to a wastewater treatment plant, and some of my favorite sites to go to is out in Calumet, where the pH of the water is so high that it's the most alkaline place in the entire world that's naturally occurring. It's so unique, and I love pollution, and I love water. One of the things that's going on right now, we're fighting wars right now about oil. We're fighting war on terrorism. Water is going to be where we're going to have our next wars. This is a precious commodity that we can live without food. We can even live without oil right now, but you cannot live more than a day without water. So one of the things I'm extremely passionate about is drinking water. How do we get clean water for everybody? When we look at the planet, we notice that there is a lot of water. I mean, we really thought about the name of our planet. It shouldn't be called Earth, it should be called water, because it's mostly water. But, you know, yeah, it's like, you know, it's this blue, ball and everything. But we can't drink most of that water. That water is saline. And so we're actually starting to think about, well, how can we desalinize that water? How can we take desalinization plants and convert the salty water to drinkable water? But right now, the technology to be able to do something like that, you need at least 2 liters of oil or an equivalent amount of coal to create 1 liter of water. It takes that amount of energy and resources to do this. So you talk about the greenhouse service and everything else. It's just not acceptable to do that. If we look at where else do we have water? If you also look at our planet, what's at the top and the bottom? Ice, frozen water. Well, we can't really drink that. Even though there have been, people who propose, let's cut an iceberg off and bring it down to New York. That won't happen. That's not going to happen. Where is most of our drinking water coming from? Well, from 2 locations. One of it is, as you're pointing out on that rivers of the world, is the surface water. We're located right by one of the biggest freshwater bodies on the entire planet. But do you realize that in this area right now, we're actually mining water and we're actually decreasing the amount of water. We actually are going to start going into deficits in water in this area. Even though when you go up to Lake Michigan, you stand and you look out, you're like, wow, look at all this water. But we have international treaties and agreements with all the different states that border the Great Lakes not to allow that Great Lake to drop. And so we can't take out any more water from that. So the only communities that actually use the lake for drinking is the city of Chicago and a few suburbs. The rest of us are all using groundwater, or the water that's below our feet. When you look at the ratio of groundwater versus surface water, groundwater makes up what most people drink. It makes up almost all the water that people are consuming. And so for my discipline, hydrogeology, that's what I study. I want to know what's happening to this invisible resource that's below our feet. How do I visualize it? How do I get this information from something that's below our feet that's moving and transforming our entire lives? How do I get information about this? How do what I'm doing today influences that? How when the last glaciers were here, how does that impact the water that we have today? And so that's one of the things that I study. These issues are becoming more and more prevalent as we look around. I'll pass around these 2 National Geographics. As I mentioned before, these came out in April. And they're just talking about all of the issues of our thirsty world and all the water issues that we're going to have around this planet and where things are going. It's becoming more and more important. Karen held up her bottle of water, and in this Reader's Digest right here talks about how safe is your bottled water. How environmentally unfriendly is this bottle of water unless you reuse it. And in actuality, one of the things I'd love to see students do is actually get these things banned from campus. I would love to see bottled water. This whole concept should just be banned from campus. If we just have a hose, you can have a hose and everything.
We did that at a school in Toronto, and what ended up happening is that they took out the drinking fountains, and so now you have to pay for any water.
Okay, now I'm not talking drinking with drinking fountains because we should be using drinking fountains. You're just talking about taking.
In other words, because the corporations couldn't sell bottled water on the campus anymore, they established a way of charging people.
Oh,
what used to be drinking fountains.
Oh, that's horrible. That's horrible. Those are unintentional consequences but the great thing about knowing about those is that if we know that that was a potential problem on another campus, we can sit there and go, how can we make sure it doesn't happen on ours? I would love to see something else happen. And so bottled water, I think, is one of our big environmental problems that we face today. I mean, if you think about per gallon rate, we're paying, $3 for a gallon of gas? But if you figure out the price of a gallon of water, and this is somebody else. This is $1 a liter, and there's 4 liters. So this is, $4 to $8, $6 a gallon for this. The thing is, do you know where this, or beer's a lot cheaper. The thing is you know where this water comes from?
My faucet.
Well, okay. It was this water, when originally we bought it bottled, came from someone else's drinking water. This is nothing special to it. This is just some other communities. Aquafina, they have a plant over in northwest Indiana. They got one in Michigan. This is somebody else's tap water. That's all this is. This is just tap water. They just bottle it. And they're not charged to pump out this water. So they can pump out this natural resource that we are using to drink, and they can charge this outrageous amount of money to pump out something out of the ground and charge you a lot of money for someone else's tap water. Two. And then think about the plastic. What's around this? Petroleum product, plastic, that they have to, where do we get our oil from?
The ground.
The ground, and from the Middle East, where we're fighting wars, so you were getting oil with Gulf. Yeah. And they keep calling this, and the funny thing is when you read this bottle, it's the Aquafina bottle. You know why they're calling it this is an eco-friendly bottle? It has half the plastic. Yeah, it has half the plastic. It's a lot lighter and everything. Saves them a lot of money. That's why they all switch to that. Just saves them money. Sorry, I'm picking on your poor little bottle of water.
That was I was glad you had.
Yeah,
it's the topic.
And then I also have another book here. I actually make my class read this. This is a book called Mirage. And this is about the vanishing waters of Florida. How many of you think of Florida, think of vanishing water? Water is disappearing. When you go to Florida, all you see is water everywhere. This is a great book written by journalists, and it talks about the water history of the state of Florida and how bad it is right now in the state, and how we're decreasing our fresh drinking water, putting in salt water in there, destroying our natural resources down there. There are parts of Florida where when you think of Florida, you think agriculture. They keep saying, we pump this water out for food, because food is so essential. But most water that's pumped out of the ground in the state of Florida is actually going for lawns, shrubbery, things like that, trees, for people's lawns, because there are people who are down there saying you have to have a green lawn. One family, they tell the story about a family who put in a drought-resistant yard, so all of the plants like they were in there didn't use a lot of water. And they actually had to rip out all of their plants in order to put in a green lawn, because the community said, you must have a lawn, it must be this size, and it has to be this certain shade of green. And they would actually, people come and check to make sure you're watering it enough to make sure the grass is green. It's horrible. It's just horrible. And talk about Disney and about how Disney destroyed all these swamps and is really bad for the environment and how they're doing. Oh, yeah. So this is another book about water. I'm like, oh. So these are just some of the things. I'll pass around these great, if you get a chance, I would love to have more copies of this journal here, the National Geographic on Water, because they're just wonderful. And so when we think about water in this area, we really need to protect this resource. We really need to be thinking about ways that we can conserve it. I had one student in a class last year who was living in this apartment where he had to pay for water. So him and his friends saw how small they could make their water bill. But then next year he's moving into a new apartment. And this new apartment allowed him to have free water. And he's like, yeah, I'm going to shower all day. I'm going to waste water. And this is not the way to think. You should be trying to conserve this water resource and how limited it is. What I'd really like to do is, I do have slides. I could go into the whole hydrologic cycle and go into this whole explanation of where our water comes from. What I really wanted to do is know if you have any questions about water, about this force that's below our ground and where it is and what do we do about it. I'd like to answer some questions. Maybe we can start a discussion here instead of me just lecturing. I mean, if you want to go to a lecture on groundwater, it's Geology 390. So if you want that, I can talk about that. I can talk about water, wastewater, anything you want to know.
Talk about the class that you guys just proposed for the new environmental studies.
Oh yeah, one of the new classes. Thank you, Melissa. One of the new classes that environmental studies. Just so you guys, if you don't know about our new major, it's a combination between the humanities and the social sciences, art, technology, the sciences, to bring together all these disciplines to look at the environment, because we all can contribute to the environment. So one of the new classes that we developed is a class called Water Quality. And in this class, we're going to be talking about microbiology of water, pathogens, disease organisms. Inside of your gut, we have a lot of bacteria in there, and where most disease comes from, you get diarrhea. Well, where did that diarrhea come from? A lot of times when you get diarrhea, it's from water. And so water gets on your food, it gets into something. And so what we usually look for are what's called a coliform bacteria. It's an indicator. It's the most amount of bacteria we have in our guts in there. And we can find it in water. And when we find it in water, we know that the water is contaminated with feces. And so you shouldn't drink it. So we have one whole section on bacteria quality of water, one whole section on the chemistry side of water. So nitrates and phosphates, that's what makes that, when you see a pond and it's that bright green color, what has happened is nitrates and phosphates have fed into that. It makes everything grow in there, and so it contaminates water. One of the other aspects, which is near and dear to my heart, is organic pollution that goes into water. So one of the things I study a lot of is pharmaceuticals. We take in a lot of drugs, especially in this country, and we excrete them out of our waste. And that gets into our wastewater treatment plants. And then our wastewater treatment plants can't handle all of these drugs we're taking. And so outside of the wastewater treatment plant, what's called the effluent, that's the water that comes out of the wastewater treatment plant, which feeds right into our Kishwaukee River. You take that bike path that goes between DeKalb and Sycamore, you walk right past the effluent from our wastewater treatment plant. And so a lot of those drugs that we're taking into our bodies come right on out and get fed into our rivers. I did a small study with an undergrad, and the student looked at when students were here and when students weren't here over Christmas break. And we looked for endocrine disrupting compounds, i.e. birth control. And so what we found was the amount of female hormones in that river was 4 times higher than it was during the wintertime, showing the impact of these 12,000 female students on campus, of which a lot of them are on birth control. You figure there's about 10,000, 9,000 women contributing pharmaceuticals and female hormones to this river. And they've shown that when you increase these female hormones in the water, you can actually feminize the fish. And so you're starting to see a transformation of fish going from male into more female because of all the hormones in there. So we're going to have a whole section about that. And then the last part of the class is with the public health department. His name is Tomoyoki Shibata, and he deals with risk in human health, and how do we look at what is the risk of you coming in contact with that water I just described. Do you swim in the Kish? Well, no. Do you drink the Kish water? No, we drink groundwater around here. So what is your actual exposure to that female hormone? Is there any exposure? Are you going to come in contact with that water, and what's the risk associated with that? And so we're combining these 3 things together in order to be able to better understand water and water quality. And so that's one of the new courses that we've just come up with. And I'm doing all the pharmaceuticals and chemicals.
I just like it because it's the first where we're going to have, College of Health and Human Sciences coming in, because environmental studies really isn't just science. It's so interdisciplinary, multidisciplinary, transdisciplinary. In order to understand it, you need to be kind of a generalist.
Exactly, and that's what I think is exciting, is that we're moving out of our
disciplines,
little tiny things, and
right,
becoming generalists.
And somebody who wants to be, because we need those disciplined people. And that's one of the things that we keep saying is that if you want to be a generalist, environmental studies would be good for you. But if you want to focus really on type, then you should go to the discipline. But we need people who understand and are translators and can talk between these different groups, so that I don't want to just spend all my time talking to hydrogeologists, because if all I did was talk to hydrogeologists, you guys would never ever know about my whole pharmaceutical study that I did here in the Kishwaukee River. I also want to do, so just a side note, I also want to do this study, so I'm trying to find a student who wants to do this. They also do studies where you can figure out the amount of cocaine use in a community, because when you take in cocaine, 90% of it comes out into your urine. And you can actually estimate the amount on campus used by when students are here, when students aren't here, and the concentration in the effluent. And so I'm waiting to find a student who wants to do that study for me, but I haven't found one who wants to do because you have to go out there and you have to sample all winter long. But you have to do organic chemistry and all this other, it's just, but that's a whole other project.
I heard a strange study about shrimp and Prozac.
Oh yeah, I heard about that. Yeah, a lot of the shrimp were actually, it's kind of funny. They made them, it relaxed them enough where they actually became more predator. They would become relaxed and they wouldn't hide as much when something was coming to attack them. They would hang out more because they were taking in so much. So yes, Prozac gets into the environment, relaxes and shrimp and everything else. Another sad thing with water and shrimp is actually in the Gulf of Mexico, the dead zone. What happens is every spring we put nitrates and phosphates in our soil here. That runs off into our rivers, that goes into the Mississippi, which goes downstream down to the Gulf of Mexico. And because that water has so much nutrients in it, it has very low oxygen in it, and there's this big dead zone that comes out of the Mississippi. And so the shrimp that are living near the bay, all of a sudden this dead water starts coming, and they start moving further and further out till the water gets too deep. And so a lot of times the fishermen know exactly where the shrimp are all going to run right into and pull right on up because of this dead zone that's coming in with no oxygen. From what we do here. So what we do here in order to grow corn to feed our cows, that nutrients is then killing the shrimp in the Gulf in Louisiana so that you can have a cheap hamburger. I mean, so the linkages between these things are just amazing on how these systems. No, cows should not be eating corn. It's actually very bad for a cow. It actually, it eats away at their stomach lining. They would die actually naturally if they only ate a corn diet. It will actually kill the cow. They're not getting enough nutrients. It also eats away at the linings of their stomach. So we have to feed them antibiotics in order to stop the infections from the ulcers from them eating the corn. So we have to feed them antibiotics to keep that down so that they can grow fast enough so that you can have a $1 meal at McDonald's. It's all linked together, and so we put in most antibiotics that are made in the United States go to animals. They don't go to humans. Production in the United States. They all go to cows and pigs and chickens to keep them so they can live in close confined quarters and so that they can live in very, very inhumane conditions. And so we create a lot of antibiotics in this country. So one of the things I'm working on, another project with anthropology, is looking at detecting antibiotics in the environment so that we can say that they are actually polluting our environment and making antibiotic-resistant microorganisms, which then come into us, which then can be flesh-eating bacteria. So again, to go back to the beginning, we put nitrogen and phosphates on the corn to feed the cow eats the antibiotic eats the resistant organism that eats us.
Right. It's a perfect circle.
There's a circle. It all links together. So that's some of the stuff that I find fascinating and interesting. Yeah. So you have other questions?
I have a question about what the water that is under us in DeKalb.
About it?
Yeah, like is it a river? Is it a lake? Is it a what is that?
Well, one of the misconceptions, I mean, a lot of times people will say, oh, we have a river. There's this underground river. And there's very, 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 very few places in the world where you actually have an underground river. Down in the Yucatan, we actually have this.
Yes.
Because you have karst geology where you actually have caves.
Yeah,
But here, we don't. We actually have all the soil. And in between all the soil particles, there are spaces in between it. And the water flows in those pores in between the grains. And so that's what we actually have below us, is the groundwater is in all the porosity of all the soil. So like if you have your platted plant and you pour water in, it's in those in between those grains. It's about 30%. So if you took the soil and it's about 70% solids, about 30% liquid or water in there.
So it's not like porous rock that water is flowing through.
It's actually in this particular, it depends on where you are. In our particular area here where we get our drinking water from, well, it depends on which well you're talking, and you're starting to get into a whole bunch of different things. That's where you start going into my brain going, well, but there's this. But so say like one of the main aquifer units. An aquifer is where we get our water from. It's a unit that we get water from, a pumpable amount of water. One of the main aquifers in this area is called the St. Peter's sandstone. It's a very clean sandstone. So it's basically sand that's all been glued together. But that glue that holds all the sand grains together does have holes in between it. And so this giant St. Peter sandstone acts as a giant filter, filtering all of our water, making it nice and clean. So when we drink it here, it's clean water. Groundwater, when it's pumped up, is generally very, very clean. So that's one of our aquifer units. Where we in the city of DeKalb get most of our water from. Let's go back in time 12,000 years. If we were back 12,000 years, what would be here right now? Well, this was the last glacial maximum. So we would be over a glacier right now. There would be a glacier, it wouldn't be a mile high. We were at the edge of it. If you go out to Creston, if you ever take 38 and you're driving down the road, all of a sudden you get to Creston, all of a sudden you're like, whoa, whoa, and then it's flat. That was the edge of the glacier. If you go up to Genoa on 23 and you're driving down the road, you get up to Genoa and go, whoa, whoa, that's the edge of the glacier there. So we have the glaciers at those points. Well, what was just on the other side of the west end of campus was called the Troy Valley. Have you guys ever been up to the Wisconsin Dells? That's what it would have looked like. You would have had this big drop off, this big valley that went all the way up to Rockford. It's this big, gorgeous area where on the edge of campus, it drops off. It goes almost out to Creston, and then it comes back up. And so that's the rocks in the area. And so we call it the Troy Valley. It was this big valley right here. We would have had some tributaries that led into it. Then we had these dam glaciers. These glaciers came in, and what they do is they fill in all of our landscape. So they smear the entire landscape with soil, make everything nice and flat around here. So they filled in this big, beautiful valley that we would have had right near us, where it would have been gorgeous. We could have had campus right on this gorge and everything. Instead, the glaciers came and filled it all up. So at the bottom of this big valley is sand. And so we punch holes into the ground, we go down to that depth, and we pump up that water. And that water is actually in contact. One of our PhD students in the geology department is actually modeling where that water flows and looking at, is there a connection between the Troy Valley and that St. Peter sandstone, so that this area is what's called a recharge zone. So the water that lands on the ground here gets into that valley, then goes into the St. Peter sandstone that places like Geneva would pump out for drinking water. So it's all interconnected. So the water that you're drinking today was a water droplet 5,000 years ago. So it rained 5,000 years ago. That water took that long to get into the ground, move, and then for us to pump it up.
See, I think that is a gift.
Yeah, so our groundwater resources are actually very old. Depends on the area. So depending on where you are in the country, it can be anywhere from 10 years to tens of thousands of years old. So your water can be a very wide range of ages. And so if you think about it, it takes 5,000 years for the water that was rained this afternoon for it to get down into that aquifer. And we're pumping it up at what rate?
Too fast.
Too fast. So so this is actually mining. We are actually mining our water resources in this area. And so this is not as simple of a matter of just, oh, let's pump it up, it's an unlimited resource, let's bottle it and sell it to somebody else. We really need to be thinking about mining that water. Now, another issue with our water around here is, as I have helped students move in to the residence halls, I've seen them come with these big things of bottled water. They've been told our water is toxic. How many of you guys have heard that our water in DeKalb is toxic? Yes.
It was radium.
It's the radium issue. And I've had students ask me, well, is that because of the Byron nuclear power plant? We get a lot of our electricity here from nuclear power. Is that related to our nuclear power plant? No. Our water has, underneath that St. Peter sandstone, there's granite under there. Naturally in that granite was uranium. One of the decay products of uranium over 1 million years becomes radium. Radium, the molecule, is the same size as calcium. And when you take calcium into your body, where does it go? To your bones. So the radium, being about the same size as calcium, finds its way into our bones. Radium is radioactive. It's an alpha emitter. What it does is it radiates out, and you can stop alpha particles with a piece of paper. But because that alpha particle hits the cells right next to the bone, it turns it into cancer. And then that radiation keeps hitting it constantly from that radium particle. So one of the things that's wrong with the water is why radium is bad, is it gets taken into us and potentially could cause cancer. The legal limit for radium in water is 5 picocuries. Just don't worry about the picocuries per liter. Don't worry about that number. Our number is 7. And that's not all the time. Every now and then we hit a range of about 7, and usually it drops off to below 7. But because we're above that magical number, at the figure, this goes back to this idea of risk assessment, if at 5 picocuries, the rate of cancer should increase by only 1 case per 10,000 people. If it's any higher than 5, we may actually have more cases of cancer per 10,000 people. So by being at 7 picocuries, we probably will have 1.0001 extra case of cancer in this community because of that level. We're actually not that high above the legal limit. There is actually... We should drink beer. Yeah, actually, that's my solution. Well, when I go to Mexico a lot, I mean, the water, you can't drink it down there because they don't do anything with their water. You have to drink the beer. You have to drink
But you're saying we could feel free to have a few glasses of tap water?
You could. Around here, you can have it. But because we have that radium, how we remove it is a water softener. All we do is we put in a giant water softener that exchanges the radium for calcium and magnesium in our water, and then we can drink that. The reason our tap water smells like a swimming pool, because sometimes, have you guys ever done that? You've gone to your bathroom and you close it up and it smells like chlorine in there? Well, because going back to what I talked about before about bacteria in the gut, the fecal coliforms in there, you have to kill off the bacteria. The best way to kill it off? Chlorine. Because that water has to come up, we have to remove the radium. Now, because we've done a treatment to it, it's exposed to the air and people, we have to make sure that there's no bacteria left in the water, so we have to chlorinate it. If we pumped it directly out of the ground and into your home, we wouldn't have to chlorinate it, but because we pump it out of the water to remove the radium, we have to then chlorinate it to kill off the bacteria. And we have to keep a certain concentration of free chlorine in our water so that your home that's at the far end of the distribution area still gets enough chlorine to kill off any potential disease-causing organisms. So when it really smells like chlorine, they got a hit, that means they got a positive sample, they put in a lot of chlorine to lower it down. Some communities don't actually do that. Have any of you been to New York City?
Yes.
They don't do anything in their water. What? Yeah, they actually don't do anything with their water. It's big reservoirs up in the northern part of the state, and they bring that water down into the community. Odd thing about it. Okay, it's surface water they bring down into it. Love this story. There is microscopic shrimp that actually live in that water that you can't see with your naked eye. And so there's these really they're small little sea monkey. They're this really tiny shrimp. And there was this big controversy in New York because of the large Jewish population in the area. What is this water not kosher now? We have to bless all of our drinking water because it's got shrimp that people are doing. And the rabbis came together and they decided it's so small, it's microscopic. God did not intend for them to have to do anything about water that something you can't even see. So, but this was a controversy in New York about the shrimp that were in the water, these microscopic shrimp. Yeah, this little teeny shrimp. Fascinating. Love stories about. I could talk on and on about water. Any other questions? Yes.
I just feel like all these problems that you're talking about are never going to stop. So I don't know what's going to happen. Because everyone's going to always take their drugs, and everyone's going to always have to do the antibiotics to the animals because they need to feed so many people in America.
Right.
So
But we can change, and that's a good point. I mean, one of the things, but the thing is if you and us as a society start to value things differently and try to think about ways we can do things differently, we can make changes. And we have done it. We've actually made substantial changes in this country. When I talk to someone like Jeff, how bad was the air quality in the 70s? I mean, you guys remember.
Oh, in LA.
Oh, in LA. You couldn't see through it. What about Love Canal? Love Canal was where water set on fire. We used to have water that... The Cuyahoga River.
Oh, remember it caught on fire.
It caught on fire. The Cuyahoga River caught on fire. Do you ever hear of that today? Do we talk about air pollution problems where you could cut it with a knife? In Chattanooga, Tennessee, they used to have the air quality problems so bad that they couldn't even see a quarter of a mile during the day. Women would talk about their pantyhose melting on their bodies because of the air quality problems. Then they came up with the Environmental Protection Agency. They came up with laws, regulations. People got obsessed upset about this, and they need a change. Now, we have water that you can actually drink. We actually have fish that swim in waters. We're bringing back wildlife. The eagles, the Cuyahoga River, now you can fish into it. We have bald eagles coming back because we banned DDT. The United States is actually better off today than we were in the 70s because people got mad. If you, as the younger generation, go, this makes me mad to hear about this, I want to make a change, we can get a change. We can get a change because of what you do. I can sit here and talk about it all day long. I can make a change, but it's really your generation, you guys getting into power, you guys wanting to say, this makes me mad, I want to make a change, and make it so that my children are not drinking pharmaceuticals from someone else, that there are better. So we can make it better.
Yeah, I was talking to Karen, and I mentioned the question of the commons.
Mm-hmm.
And
Yes.
the issue becomes like, where do you draw these lines between at what point do you set limits on what people can do for private gain and what they can't? And people contest over those issues because we are competitive animals as well as cooperative animals. Mm-hmm. And we're a capitalist society, and yet people don't want to drink contaminated drinking water, nor do they presumably want a bank to sell them a mortgage that has such hidden provisions that they wind up going bankrupt as a result. So, this is the big issue in politics. Mm-hmm. Where do you put these regulations so that they benefit a broad mass of people and at the same time don't prevent people from taking reasonable steps to sell things that people want because it gives them pleasure to buy.
Yeah. And it's a really quick. Oh, Jason, yes. All of a sudden, Jason's like, oh, but this idea, and that is a philosophical idea. This idea of the commons is what is common? What do we do? Who owns the Kishwaukee River? Who owns that water? Is it you? Is it me? Is it the city of DeKalb? Is it the state of Illinois? Is it the federal government? Who owns that water? Can I just pump it out? And even though it may have an impact on you downstream, do I have rights to it? And it's interesting is that if you look at like a book like Mirage, which talks about Florida and Florida water issues versus the Western idea of water is the first come, first served. The first person out there gets the rights to that water. In the eastern United States, we don't have it. We have to actually impact the downstream people. But in the western, it's I was here first, I get as much water as I want. I really don't care if I dry out the river to anybody else as long as I can grow my crop here. And so people can sell these things, and there's a great book out there called Cadillac Desert. It's also a documentary called Cadillac Desert, and it talks about the water wars of the western United States. Fascinating book, great book. I like this one better for classes. It's more current and by a journalist. That other one is a little bit heavier in thinking and stuff. It's a great book, but this one really talks about these water issues. This idea of the commons, and should I drink water or get mineral resources? Mineral resources is the same thing. It's below ground. Who owns below ground? What's that one? Will There Be Blood, about the oil?
Yeah.
Is that one? And he talks about the giant straw going out. He can suck oil from anybody's property.
Yeah.
You don't own what's below you. You only own the surface, but the mineral rights and the water rights, out west. And so it is the commons.
But it's interesting when you're mentioning this. I think I want to play devil's advocate just a little bit and understand that vision. But I think there's going to be an argument that says that the free market of water, the fact that companies like Aquafina are doing this bottling, and that water becomes a traded commodity, absolutely traded, which is something I think it's, what's his name, Barnett, the guy in Texas.
Oh,
Booker,
yeah.
I can't even, Booker T. Barnett, something, what's the guy's name? Who bought up all the water rights throughout the West. He's an oil man. T-Bone Pickens. And there's a thought that by the free market of water, will you have will the incentives then afford You know, I think that's an interesting argument. I think that history has shown that no, it's probably not the case.
No. I mean, and to me, water always comes down to water. And it's one thing that's a commodity for, say, gold, diamonds. I mean, gold really has no value. Diamonds actually has, because of De Beer, make diamonds actually worth it. Diamonds are actually completely worthless. They're carbon, they have no value whatsoever. We make them valuable. We don't need diamonds. Water, on the other hand, in my mind, is a completely opposite thing. You cannot live without fresh drinking water, so therefore it shouldn't be controlled by a market base where someone who's poor, and they've shown this around the world, in places like Peru and Bolivia, where they start to privatize the water, and then all of a sudden these people come in, and the poor people can't afford water, they can't drink anything anymore, they're dying, they're using wastewater, they're going into extremely contaminated because they can't afford to buy the thing that keeps them alive in a very bad area. It's one thing, I have free market, great, let's make something, useless, I mean, really, honestly, when we start thinking about what we value in this world, we should be thinking about what really is a necessity for all, and that should be the highest value, not, what jewelry we're wearing. I mean, it's amazing how much people pay for really a chunk of a rock, which is nothing. I mean, really, I'm still amazed diamonds are worth anything.
Well, those are like
Major.
sanctuary goods.
Yeah,
Major
but
religious leaders have actually said this in some ancient texts.
really,
Yes,
that's
they have.
fascinating.
The rabbis have come down on this issue.
Yeah.
But I think one of the great things about water and about just our local watersheds, how it impacts on our early attempt to make a plan for a common space. I mean, we're talking about the Living Lab project. We're talking about, first of all, something that will be a commons.
Right.
It will be, and it will, because the space that we have in our imagination targeted is on the banks of the Kishwaukee. It immediately impacts that area. So the beginning of our planning, we have to acknowledge, first of all, that anything we do will impact the Kishwaukee, which impacts the Rock River, which impacts the Mississippi. So if I spit in the Kish, sooner or later, some fish in the Gulf is going to go, I place or I. So I think that's one of the reasons that we wanted to think and talk about water itself, is that we're actually going to be dealing with this directly pretty soon.
Yeah, and water, like you had mentioned, and when you talked about this, is water is everywhere. I mean, water is everywhere, and what we're doing at the Green Roof, one of the great things about this, and why we want to make this a research project, is being able to take water and not be a waste product.
Right.
Not go into a sewer, not go into a waste, but can it go into something that grows something that becomes beneficial? Beauty, can it become clean? Can we clean it up, or instead of this just becoming a waste product and dirty? And so I think this is a great thing that you guys are trying to do, is by doing this green roof and making it so that people can see it and visualize it and know what it really is. They're taking this abstract concept of water and water movement, this whole hydrologic cycle that we're trying to talk about in here, and making it something that they can actually feel, see, touch right here today, instead of this big concept of where water comes from. And so I think it's a great thing you guys are we're trying to do together, and we're really bringing in here. And I'm very passionate about water. I mean, that's, as you can hear about my talks here, it is my passion. And and we need to protect this for the future. This is the most important. In actuality, just so you know, for the environmental studies major, one of the emphasis is on water. You can get a whole degree with this environmental studies degree on water, on all aspects of it, from the human to the contamination to all aspects, the political wars to issues in Florida to is your drinking water safe to the chemicals that are going into it and everything else. So, that's one of the reasons that we have that whole thing there, is just to be able to do that. And I would love to have a class where we have something more where we're joining these forces.
I know.
And where I'm taking these concepts here and how do I make it accessible? I would love to be able to do something like that.
Well, I'm going to stand up with you then, so that we can talk together. Because that's one of the ideas of Living Lab, I think, was the idea that, first of all, it's a communal space, it's a social space. It's a place where you can be both, go with others and also be alone. So there's opportunity for a contemplative moment or for jamming with the band. So part of the research trips that we've set up include visits to other sites where other people have had those ideas, and we'll see how big ideas have played out over time. So we're going to go take a Segway tour of the Chicago lakefront and have a look at how Frederick Law Olmsted's big idea looks now, and how it's, you take a big idea, you shape the coastline, you plant some trees, you get an idea about how people relate to it, and then 100 years later, we want to see how it's grown, how that idea has expanded or been subverted, or what's happened to it. So we'll do that. We will go and look at some green roofs. We're going to go up to Rockford and also Beloit. In Rockford, we'll look at the Anderson Garden, which is it's actually a Zen garden, and the essence of that garden is it has to do with revealing to yourself the very nature of perception, and also it's incredibly beautiful in October. So even if you don't want to engage in deeper issues of perception, you can just fall in love with your own beautiful eye that gives you all this pleasure. And then we'll toot up to Beloit College and look at the remains of Shia and Johnny's poetry garden, which was commissioned by the Lannan Foundation in Los Angeles. When they moved, they decommissioned it, and a little bit of that is up at Beloit now. Well, all of what there is up there at Beloit. But they made the coolest space out of trees. They made green rooms out of trees.
We've seen it.
Yeah, we've seen
Yeah,
it.
you guys have seen
Yeah,
it.
it's
These
great.
guys haven't. We're going to take a trip up there. It's nice.
It's very nice. It's
Yeah,
very interesting.
I love those platforms.
Yeah.
You could do Shakespeare. You could
Yeah, they do that. They do
Yeah.
that.
And you can, or you can just sit and have lunch. 30 inches high. It's table height. So we're going to go look at that, and then we're going to sit down and think about our site and what could happen, what we could do. So I think that's what we're going to do. And your department will have its ideas, and it's. I mean, part of designing the use of a site has to do with figuring out what people need.
Mm-hmm.
Your needs, our needs, your needs. All of that comes into play. So I'm really excited about it.
Yeah, I think this is a great partnership,
Yeah.
and I'm really hoping that other colleges and other people on campus too
They're
get this
gonna want
idea.
to play.
Exactly, are going to go, oh,
we can
those
do
are,
that.
that's really cool. Oh, maybe we can play. Maybe we can get into the sandbox and have some other
Dinner parties
components.
could be involved, and there could be cake.
Yeah, exactly. So we can bring in a lot of people, and I think this is one of the great things about that makes me excited about it.
Yeah.
Again, I mean, other than it's I'm excited that we're actually able to do some of these things and really get these things going. And
We're walking across campus too.
oh, no problem. I never leave.
leave.
Well, it's like me. I never leave Davis. I'm like, I called Melissa last week. I'm like, I have no idea where AB 100 is, and I'm wandering around. I'm like, this is the art building.
Go find the art ghetto.
Oh yeah, I never leave my building.
That's
You've been to my building.
Yeah, I think you're doing once.
Yes, no.
It was interesting.
Yeah.
You have different pictures on the wall.
Yes, we
What about the students who walk by the Kishwaukee Park? Like the Kishwaukee River?
The what?
Oh, the Kishwaukee, what about it? Just
What about walking by?
Because of all the minerals and everything that you're discussing and the amount, the way it's affecting the whole ecosystem, what happens with all the students that walk by the Kishwaukee?
Not much, because you're not actually coming in contact with it. So as long as you don't go swimming in it, you're not eating the fish out of it, you really are not having any contact with it.
Well, what's it like? What's the
Well, the water safety, like right here, is not bad. The water I'm talking about is downstream from the wastewater treatment plant. So as you're going through Hopkins Park, as you get into Hopkins Park, that's where we're seeing all levels. We do see a lot more algae. We do see a lot more phosphates in the water. We can see decreases and changes in the water quality and chemistry. But the actual physical, unless you play in it, you're not going to have that much contact with it. But the thing is that water then recharges the aquifer. And a question I have, and this is something that actually hasn't been studied yet, and that's one of the things I'm working on is, well, that I'm saying, well, unless you come in contact with it, but how do I know those pharmaceuticals don't go through the soil and get into the groundwater? We don't know that, honestly. Scientists don't know the answer to that question. There hasn't been any research done on that. we're just starting to understand
It takes
because our
how many
detection.
years for that?
Well, it takes so many years to get into the water. Part of the other problem is our detection limits in water. When you're talking about when I'm seeing these things in the water, the analytical equipment has finally caught up to the point where we can actually see them in the water. We used to not be able to even see them in the water, so we didn't know they existed in the water until we started getting to the point where we can actually test for it. That's why those shows like CSI get me so mad as they sit there and they, oh, look at that water in there. Oh, you see that? Oh, yeah, now that water can only come from 3 places, and if you da-da-da-da-da, and we go arrest the person. It doesn't happen that way. My husband's like, it's only TV, and I'm like, so I get really mad at those shows.
Oh, well, the guy who writes for that is going to be at the Chicago Humanities Festival.
Really?
Yeah.
He gets so mad.
Yeah.
And he takes a little bit of science and like extrapolates it to something we can't do. So we finally got it to the detection limits so we can actually see it. And so now that we have the detection limits, we actually have to do the basic fundamental research is, can that pharmaceuticals make it through the soil and get into drinking water supplies? And so I started doing some of that research projects to start to do some of that. And we were doing it on looking at septic systems, septic tank systems, which if you're in a rural community, your drinking water well is generally very shallow. You have your septic system in your backyard, your drinking water in the front yard. And so if you're taking drugs, your neighbor is, there's a shallow, very shallow recharge and can quickly get into your drinking water. And so we were looking at meth, and we were looking at if you were living, say, next to a meth house, can that methamphetamine actually make it into the water supply and you could be drinking it later on? And we are finding it, that we get a certain amount of decreases through the soil, but we're actually seeing meth can make it through pretty deep into the water system. I'm working on that publication right now, so hopefully they'll get out into groundwater, and then maybe we'll release, some sort of news release. One of my goals in life is to get on the History Channel or Discovery Channel, a scientist, sitting there. Well, yes, that's one of my goals in life. I have high goals. That is one of those. So I'm hoping with my meth project we can do that. But that fundamental question you just had. I know you didn't say that. Oh, if you wanted to, I can tell you stories about trying to get meth. How we get it. We put in $40,000 street value of meth through a soil column to find out these answers to that. We didn't pay anything for it because actually the federal government has this whole plan for scientists and other people and for drug dogs and everything else. The drugs that are seized and the government owns, they redistribute parts of them back to scientists, to the canine drug labs, to those things. To train them, because where are they going to change? How are they going to get the meth to train the dog to find it?
Steal it from them?
Basically they do. They get it and they reallocate it back out to people. So we can get it from the federal government. So we didn't pay it. Yeah, absolutely. And it's actually easier for me to do research on meth than cocaine. I could never do research on, say, marijuana because of the classifications of it. There's no way I have enough security in order to do that type of research. I can do these really actually horrible drugs. Yeah,
I was going to say marijuana. That's pretty scary.
It's very scary. I'm like, oh God, I can't do research on that, but I can do that. Yeah. So this is part of what I find fascinating.
I know last week when Francis Whitehead was here and talking about, we live at the trifecta. What was the trifecta? Water, soil, and people? I don't remember. Water and soil was what I thought, but it made me start thinking, I love this idea of the living lab, and we represent like what's going on now, but I'm thinking, well, what do we want to see happening? I mean, because we could be representing, like this, monocrop of corn and soy and all that, or do we want to see, like the region going towards more diversified crops so that, if there is some type of famine or something, because we will be the breadbasket, we are a breadbasket, but a lot of our food right now is cattle production.
Yeah, our soil is the most productive soil in the world, and it all goes to feeding cows.
Yeah.
None of it goes to feed people. It all goes to feed the cow. That then goes to feed the people. Well, in this region, almost all of our corn, there's different types of corn. Like the corn in the lower state part of Michigan all goes to Kellogg. In area of Indiana goes to popcorn. In this area, almost all of our corn goes to feed.
Yeah.
Yeah, it depends. But that's all. So everybody else has any questions